Okay, YouTube, this is my first in a series of videos in which we're going to explore how we can write the equations of quadratic equations given certain, initial information. And so what I want to look at here is I've got this table up at the top in which I give three different situations and then the process we use for those three different situations. But when it comes to writing the equation of some parabola here or some quadratic data, we're basically going to need to match it to which situation is appropriate for the situation that we have given. So we have the three situations of these. If we have a point xy on the graph and the vertex value, then what we'll do is we'll just use vertex form to write this equation. Whereas if we're given a point on the graph, so we still have some point, we should call this point xy, and x-intercepts p and q, then what we'll do is we'll just go insert this information into this intercept form where we have our two intercepts, x and y. And then last but not least, if we're given at least 3 points on the curve and we are very, very sure that it's quadratic data or quadratic, model, then we can write and solve a system of three equations in three variables, but we'll be using equations in standard form. So you'll notice we have vertex form up top, intercept form here, or we'll be using standard form equations, whichever is appropriate to the situation. So let's take a look at this first example. It says the graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled, also in feet. So what we are interested in doing here is writing the equation of this parabola. And then we say that the performer lands in a net 60 feet from the cannon. What is the height of the net to the nearest foot? So let's start with this equation part. And what we see over here on the graph is we have our y variable, which is representing height in feet, and our x variable, which is our horizontal distance in feet. We can see how this person was shot out of the cannon, and we see their path. The interesting part of this is we're already privy to some given information, and that information really are these parts. We say that we are aware that the vertex, which is this value of h and k when you talk about vertex form, we're given these two values. So this person 25 feet away from the cannon is at a height of 30 feet off the ground. And we're also given this other point on the graph. We say this is the point x comma y. Now I do want to point this out. We have this point over here, but we're not quite sure what it is, and that's the one we're going to solve for when they're 60 feet away from the net. Approximately how high off the ground are they? We know it's going to be in this neighborhood of 10, but we want to use the equation to do this first. So since we're already given this information, the vertex and a point, what we're going to do is we're going to use this first situation where we write this in vertex form. So the way this works is because vertex form has this information right here, where h and k are vertex values, and we have x and y or some point, what we're going to do is we're just basically going to make substitutions for all the data that we know, and we're going to work backwards to solve for the data that we don't know. So because we know x and y, you'll notice that I took x and y out of this equation, this x and this y. And I also know h and I know k. So we're going to substitute in these values, and really the only value we don't know in any of these instances really is going to be this value of a. So we say let's plug in what we know. Now because I know x and y respectively are 0 and 20, we'll plug in a 0 for x and a 20 for y. And also because I know that the vertex values are 25 and 30 for h and k respectively, for h we will put in a positive 25. Notice that we're subtracting a positive 25. That's important. We have a positive 30 here. So let's go ahead and take a look at what this simplifies out to being. We have 20 on the left side of this equation. We have a times, now 0 minus 25 is negative 25. So we get negative 25 squared plus 30. So 25 squared, I do believe, is 625, but we do want to check this on a calculator. So what we end up with here is this. We have negative 25 times negative 25 is the same thing as 25 times 25. So we do indeed get that 625. So we get 625 times a plus 30. And now all we want to do is solve for a. So by subtracting 30 from both sides, we see that we get here a negative 10 on the left and a 625a on the right. And dividing both sides of this equation by 625, don't be upset by the fact that we're going to get a supreme fraction here. Or in this case, I'm actually willing to go for a decimal. So we say, let's clear this, we get 10, which is negative, divided by 625. We get we get exactly negative 0.016. So what we've just determined is this negative 0.016, this is the value of a. The reason why this is pretty neat is because now we can go back and write this equation again, except for this time we are going to leave the values of x and y general. That is to say, we know a, we know h, we know k. We can go put those things in, and in vertex form we'll have the equation of this parabola. So we have y equals our a value, which is negative 0.1 negative 0.016 times x minus, now our h value here was positive 25, so we're taking away a positive 25, which makes it look like a negative 25. We have that quantity squared plus 30. So looking at this, we can say, well, it makes total sense that our vertex is at 25, 30 here. And because we have a negative a value, it's going to open downward, and this is some really, really proper fractions. So this would be a wide-shaped arc that this would go through. But now using this information, it says, well, if the performer lands at a net 60 feet from the cannon, what is the height to the nearest foot? So really what we're being asked to find here is what is the height? And we say that's really the y value. And we're given some x value here. So we say when x equals 60, really what we're trying to solve for is what is our y value right here. And we know it's going to be around 10. So we would go ahead and plug this in, substitute in for x, our x value, which is 60. So we'd say 60 minus 25 squared plus 30. And so we will need a calculator to carry out this computation. That's not so bad. We say 60 minus 25, since it's in parentheses, we'll do that first. And so we'll take that 35 now and we'll square it. So we have y equals negative 0.016 times 35 squared plus 30. So squaring out our 35 now, I'm just going to go ahead and hit my square key. Now I'm going to take that now, do our multiplication next, times 0.016, which is negative. So we get this negative value, and I'll add 30 to it. And when I add 30 to it, we get 10.4. And so we'd say approximately, well, it's equal to 10.4 feet. But we did want to round this to the nearest foot, so we would say this is approximately 10 feet, which is supported by this graph. So for the next part of this video, what I would encourage you to do is pause it and actually try to figure this one out on your own. But what I want you to see is, again, we're given some point xy here, and we have the vertex values h and k. So what you should do is, in vertex form, let's go ahead and substitute these values in. So now if you're interested in seeing the solution now, I'm actually going to follow through and show you what we would get in this case. We'd say a, we're going to solve for a. But we'd say that our x and y values, now this point x and y we have respectively negative 1 and positive 2. So our x value is negative 1, and our y value is positive 2 when x equals negative 1. And then our y values here, or sorry, excuse me, not y values, but our vertex values, our h and k, are 4 and negative 9 respectively. So we'll put in a 4 for our h, and we say a negative 9 for our k. So again, let's go ahead and simplify this. We end up with 2 equals a times the quantity. Now negative 1 take away 4, this is going to be a negative 5 squared plus negative 9. So let's go ahead and square our negative 5 here, which will make it a positive 25. So we get 25a. I'm just going to go ahead and write minus 9. So now again, we want to solve for a in this case. Once we have a, we can write the true equation here. We have 11. This is 25a. So we can determine that dividing both sides by 25 here, that a is equal to 11/25. Or another way to write this would be, when you put in a calculator, 0.44. I happen to know that 25th is 0.04. So, take that times 11, you get 0.44. So anyways, you get this a value here. So writing this equation, we would say, now leaving x and y general, let's plug in for a what we have for a decimal. So our a value is this 0.44, x minus our h value, which we were observing was 4 to begin with, squared. We say plus a negative 9, so I'm going to write minus 9. So we definitely have a vertex value at positive 4, negative 9. And this would be some vertex, or sorry, some parabola that opens upward and would be somewhat wide.